A shape bigger than worlds is hiding under Jupiter's clouds, and it is moving even now. It does not shine, and no telescope can show it to your eyes. NASA only sees it when a spacecraft feels tiny changes in gravity and magnetism. That is how Jupiter starts giving up a secret it kept for billions of years. If you like space stories where the facts are real and the mystery gets deeper every minute, subscribe and stay close. Some of the strangest things in the solar system are still being uncovered. Jupiter has always looked like the easiest giant planet to recognize. You see bright bands, dark bands, swirling storms, and that famous red eye staring back through a telescope. Even a small backyard telescope can show that this world is not just a plain point of light. But the more familiar Jupiter looks from far away, the more misleading that first look becomes. That is because Jupiter does not really have a normal surface at all. There is no ground to land on, no rocky plain, no mountain ridge waiting under the clouds. What it has instead is layer after layer of gas, pressure, heat, and crushing depth. The deeper you go, the less the word sky even makes sense. For centuries, people could only study that outer face. Galileo saw Jupiter's moons in 1610 and helped change the way humans understood the solar system. Later observers tracked the bands, measured the planet's fast spin, and watched storms drift and grow. But everything below the top clouds stayed hidden, like a locked room behind a painted door. Scientists built models because that was all they could do. They used math, light, heat, radio waves, and old probe data to guess what the inside looked like. Some ideas were strong and some were little more than careful bets, but many of those bets started breaking apart the moment NASA got close enough to test them. That is where Juno enters the story. NASA launched the Juno spacecraft in 2011 and sent it on a 5-year trip across space. It traveled about 1.7 billion miles, which is around 2.8 billion kilometers, before reaching Jupiter. On July 4, 2016, it fired its engine and slipped into orbit around the giant planet. Juno was built for one hard job. It was not there to float through pretty clouds and send back only nice pictures. It was there to measure things humans cannot feel from Earth, like gravity shifts, deep heat, and the shape of Jupiter's magnetic field. Those invisible clues are what let scientists probe below the cloud tops without going through them. That matters because diving into Jupiter is not simple. The pressure rises fast, the winds are violent, and the radiation around the planet is brutal. A normal spacecraft could be damaged quickly if it stayed exposed too long, so Juno had to work like a careful detective, passing close, collecting clues, then swinging back out again. At first, many people imagined Jupiter's hidden layers in a simple way. They pictured a large gas planet wrapped around a solid center, with weather mostly near the top. The bands looked like surface decoration, and the famous storms looked like giant but fairly shallow weather systems. That version was clean, easy to picture, and wrong in some important ways. The first cracks showed up in Jupiter's gravity. As Juno flew by, the planet tugged on it in tiny, precise ways. Those tiny changes told scientists how mass is spread inside Jupiter, even though they could not see the mass directly. And the mass was not arranged the way older models expected. What experts thought they had was a neat, giant planet with clear inner layers. What Juno began showing was a planet with a messy, mixed interior that did not fit the old design. That gap matters because gravity is hard to fool. If the spacecraft feels a strange pull, something real and deep inside the planet is making it happen. Now the story gets sharper. One of Juno's biggest findings was that Jupiter may not have a small, clean, solid core at all. Instead, the data points to a much larger inner region that is blurred out and mixed with the layers above it. Scientists call that kind of center a dilute core, but most people know it as a fuzzy core. That phrase sounds soft, almost harmless, but the meaning is huge. A fuzzy core means there may be no simple boundary where Jupiter's center ends and the rest begins. Heavy material appears spread through a vast region instead of sitting in one tight ball. In plain words, Jupiter's heart may be broken up, smeared out, and mixed into the planet itself. Why would that happen? One serious idea is that something massive struck young Jupiter long ago, maybe a planet-sized object several times the mass of Earth. A giant impact like that could have stirred the inside so violently that the original core got partly dissolved and spread out. If that happened, Jupiter still carries the scar of that ancient collision hidden far below its clouds. That changes more than one planet's life story. Jupiter is the biggest planet in our solar system, and giant planets around other stars are common. So if Jupiter grew through collisions, mixing, and deep internal chaos, many other giant worlds may have done something similar. A single finding below Jupiter's clouds can change the way scientists picture planets across the galaxy. Did you expect the largest planet around the Sun to hide a broken, blurry center instead of a clean core? If that surprise hit you, tap like and tell me which part sounds strangest so far. And if you want more real science mysteries without the fake drama, subscribe and keep going with me. But Juno was not done. Long before this mission, scientists had studied Jupiter's colored bands and fast winds from a distance. Those bands are called belts and zones, and they wrap all the way around the planet. Many people assumed they were mostly shallow, like patterns painted near the top of the atmosphere. That guess made sense for a long time. You can look at Jupiter through a telescope and see the stripes clearly. They seem like the obvious surface layer, the part sunlight reaches and cameras capture. It was easy to believe the deeper planet below them might be calmer, smoother, or at least less tied to those visible patterns. Juno changed that picture too. By measuring gravity, the mission showed that Jupiter's jet streams reach about 1,900 miles, or 3,000 kilometers, below the cloud tops. That is not a thin top layer. That is a deep-moving system stretching far into the body of the planet. Try to picture what that means in everyday terms. 3,000 kilometers is farther than the distance from New York to Denver. It means the winds shaping Jupiter's bright stripes are not just skimming the top. They are rooted deep inside, like giant rivers of motion cut into a world with no solid shore. This is where the mystery starts feeling larger than weather. On Earth, clouds can hide storms, but the ground under them still stays itself. On Jupiter, the weather is part of the planet's body. The stripes are not paint on the outside of a ball. They are signs of deep flows shaping the giant from within. What experts expected was a simpler split between outer weather and deeper structure. What Juno found was that the weather reaches downward and connects to the planet's internal mass. That gap matters because it tells us Jupiter is not layered in the easy way older textbooks often suggested. Its outside and inside are more linked than people thought. There was another old puzzle waiting under those clouds. In 1995, NASA's Galileo probe dropped into Jupiter's atmosphere and measured surprisingly low water in the place where it entered. That result puzzled scientists because water helps tell the story of how a giant planet formed. If Jupiter was too dry, then some ideas about its birth had to be rethought. But there was a problem with treating that one result as the whole truth. Galileo may have entered an unusually dry part of the atmosphere, not an average one. That would be like testing Earth's water supply by landing in the middle of a desert. You get a real answer, but not the answer for the whole planet. Juno had a better view. Its microwave instrument could sense deeper below the visible clouds and help estimate how water was spread. Near Jupiter's equator, Juno found that water was more abundant than Galileo's single dive had suggested. So once again, the planet looked one way at first, then turned out to be hiding a different story underneath. That matters because water is not just about rain. Water helps scientists understand the material that built Jupiter when the solar system was young. It gives clues about where ice formed, how matter moved, and how giant planets gathered their mass. If Jupiter's water story is different, then parts of our own solar system's origin story shift with it. And then came the storms. Before Juno, lightning on Jupiter was expected to work in a way that at least felt somewhat familiar. Scientists thought most flashes should come from deeper water clouds, not from the high, colder layers above. That made sense if Jupiter's storms were giant versions of storms we already knew on Earth. Juno saw something that broke that expectation. It found lightning much higher in Jupiter's atmosphere than many scientists had predicted. NASA called it shallow lightning because it appeared in upper regions where the conditions seemed too cold for normal Earth-style lightning. That was a direct challenge to the older way of thinking about how Jovian storms work. So how can lightning happen there? The answer seems to involve ammonia, a gas that can mix with water and change how freezing works. Instead of pure water ice behaving in the usual way, ammonia helps form slushy mixtures in colder layers. Those strange mixtures can create the right conditions for electric charge to build and discharge as lightning. And that leads to one of the strangest words in modern planetary science: mushballs. Scientists think strong storms on Jupiter may create clumps of ammonia and water ice, like dirty frozen slush balls. These mushballs can fall deeper into the atmosphere, dragging important chemicals down with them as they sink. That idea helped solve another mystery. Juno had seen odd patterns in Jupiter's ammonia, with some regions looking strangely low where scientists expected more. Mushballs offer a way to move ammonia from upper layers into deeper ones. So again, the pattern repeats. Experts expected something smooth and steady, while Jupiter revealed something messy, active, and hidden. Can you imagine a thunderstorm so strange it makes chemical slush and drops it into darkness? If that picture is stuck in your head now, leave a comment and tell me what you think Jupiter would sound like inside one of those storms. And if you want the next twist, subscribe, because the poles are even wilder. For a long time, Jupiter's poles were almost a blank. From Earth, and even from earlier missions, we mostly saw the middle of the planet and its long stripes. The poles were hard to view well, which meant they stayed mysterious. People knew they existed, of course, but not what kind of storm systems lived there. When Juno finally gave scientists a clear look, the poles did not look simple at all. At Jupiter's North Pole, there is a central cyclone surrounded by 8 other cyclones. At the South Pole, there is a central cyclone surrounded by 5 others. The arrangement looks less like random weather and more like a giant rotating pattern locked into place. The sizes are hard to overstate. The North Polar cyclones measure about 2,500 to 2,900 miles across, which is roughly 4,000 to 4,600 kilometers. The South Polar ones are even larger, about 3,500 to 4,300 miles wide, or 5,600 to 7,000 kilometers. These are not tiny swirls sitting at the edge of a map. They are continent-sized systems. And here is the eerie part. They do not just smash into each other and disappear. They remain arranged around the poles, shifting some, bumping some, but holding their overall patterns across time. That means powerful balancing forces in Jupiter's atmosphere are keeping giant storms in a kind of uneasy order. Scientists had not expected that kind of stable storm geometry. It is one thing to imagine a chaotic gas giant with powerful winds. It is another thing to find huge cyclones behaving almost like pieces in a moving pattern. That gap matters because it hints that the forces below the clouds are organized in ways researchers are still trying to explain. Jupiter's most famous storm was also waiting for a deeper look. The Great Red Spot has been observed for centuries and is one of the best-known sights in the solar system. Because it is so visible, many people thought they already understood it well enough. It seemed like a giant storm, yes, but still mainly a feature of the upper atmosphere. Juno went after that assumption too. In 2017, the Great Red Spot measured about 10,000 miles wide, or around 16,000 kilometers. That made it about 1.3 times as wide as Earth, and its roots reached roughly 300 miles, about 500 kilometers, below the cloud tops. That does not sound as deep as the jet streams, and it is not, but it is still much deeper than a simple surface stain. It means the Great Red Spot is not just a mark painted on Jupiter's face. It is anchored into the planet's atmosphere in a way that gives it more strength and staying power than a shallow storm would have. This is why Juno's findings feel so powerful when you line them up. The core is not as neat as expected. The bands are not as shallow as expected. The lightning forms where it should not, and the poles hold patterns nobody guessed. Even the most famous storm on the planet turns out to have hidden depth. But one of the strangest discoveries is something you cannot see with your eyes at all. Juno detected a hidden feature in Jupiter's magnetic field called the Great Blue Spot. It is not a blue storm on camera. It is an intense patch of magnetic field near the equator, sensed through instruments instead of visible light. Most people picture a planet's magnetic field in a simple schoolbook way. Maybe not perfect, but smooth, centered, and roughly balanced. Jupiter's field turned out to be much more uneven and much more lopsided than that. The Great Blue Spot is one reason why. Even stranger, it seems to be moving. Juno data showed that this magnetic feature appears to drift eastward over time. The speed is tiny, about 2 inches per second, which is around 4 centimeters per second. But on a world as huge as Jupiter, even that slow drift becomes important across decades and centuries. At that pace, scientists estimated the Great Blue Spot could circle the planet in about 350 years. Think about that for a moment. There may be an invisible magnetic scar sliding beneath Jupiter's cloud bands right now, tracing a path no human will watch from start to finish. That is the kind of hidden motion Juno was built to notice. Why would a magnetic feature drift at all? Because the field is tied to what is happening deeper down. Inside Jupiter, pressure becomes so extreme that hydrogen gets squeezed into a form called liquid metallic hydrogen. That means it is still hydrogen, but under crushing conditions it starts acting like a metal and carrying electric current. That deep metallic layer helps create Jupiter's massive magnetic field. So if the field is uneven, drifting, and full of strange features, the hidden layer making it may also be uneven and moving in complex ways. Once again, the clouds are not hiding one simple object. They are hiding a deep engine shaped by pressure, motion, and electricity. Does the Great Blue Spot sound more unsettling to you than the red spot? If you had to choose one hidden feature below Jupiter's clouds to see explained first by future missions, which one would it be? Drop that answer in the comments, hit like if this story keeps getting stranger, and subscribe for the next deep dive. Now the tone changes, because this is not just about what Juno found years ago. It is about what those findings are still doing to science right now. Researchers are still testing models, arguing over details, and trying to connect the deep winds, the fuzzy core, the water, and the magnetic field into one picture. Jupiter is still shaping active science, not just filling old history books. That ongoing part matters. A mission like Juno does not hand over one final truth wrapped in a bow. It sends back streams of data, and scientists spend years turning those clues into better models. Each new paper can sharpen one answer while reopening another question, which is why Jupiter still feels unfinished. And unfinished is exactly the right word here. The central mystery is no longer just what is under Jupiter's clouds. Now the bigger question is how all those hidden layers work together at the same time. How does a fuzzy core affect the planet's gravity, winds, chemistry, storms, and magnetic field across billions of years? That is not easy to answer because Jupiter is not standing still. It spins in less than 10 hours, which means one Jovian day is shorter than half an Earth day. Its atmosphere churns constantly, its deep interior squeezes matter into forms we do not naturally see on Earth, and its magnetic field stretches through a huge region of space. The deeper you go into the Jupiter story, the more it stops feeling like a single planet and starts feeling like a whole system. The clouds react to the winds connect to the interior shapes the gravity and magnetism. Then those things affect the environment around the planet and even help govern conditions for its many moons. That is one reason scientists care so much. Jupiter is not just another object in the sky. Its gravity helped shape the young solar system, pushing and pulling smaller bodies while Earth and the other planets were still forming. If Jupiter's birth and inner structure are different from what people once believed, that can change parts of our own origin story too. There is also a bigger reason. Astronomers keep finding giant planets around other stars, many of them similar in size to Jupiter or even larger, but they are so far away that we often know only rough details about them. Jupiter becomes the test case, the close example that teaches us what giant planets can hide beneath a bright outer shell. Before Juno, it was tempting to reduce Jupiter to a quick description. A giant ball of hydrogen and helium, a striped world with one huge red storm, a simple gas giant. That description is not exactly false, but it is like calling Earth a rock with air and thinking that fully explains oceans, weather, continents, and life. Juno forced people to trade that simple picture for a richer one. Jupiter is a place where deep winds carve through thousands of kilometers of atmosphere. It is a place where ammonia and water can make slushy hail like mushballs in violent storms. It is a place with hidden polar cyclone patterns, a mixed-up center, and moving magnetic structures no eye can see. This repeating pattern is what makes the mission feel almost dramatic. Scientists expect one clean thing. Jupiter gives them something deeper, stranger, or less tidy. Then they build a better model, only to find another surprise on the next pass through the data. It is like the planet has spent centuries waiting for us to stop underestimating it. Take the old idea of a simple layered giant. It sounds nice because human brains love neat stacks and clear boundaries, but Jupiter seems to resist those easy borders. Its inner material may blend outward, its weather may reach downward, and its magnetic behavior may come from hidden motions that are still not fully pinned down. The real world, once again, turns out messier than the cartoon version. That may sound like a small detail, but it is not. Science improves by finding out where the neat cartoon fails. Each failure forces better questions, better measurements, and better tools. Juno did not just add facts to a pile. It changed the questions scientists ask when they think about giant planets. And there is a human side to that. People built a machine, launched it across billions of miles, threaded it into orbit around the largest planet in the solar system, and taught it to sense hidden truths through tiny changes in motion and fields. That is one of the most impressive forms of curiosity humans have ever created. We cannot touch Jupiter, yet we have learned to listen to its hidden layers from far above. Jupiter also makes that job dangerous. The planet's radiation can damage spacecraft electronics, which is why Juno carries a heavy protective vault for key systems. Every close pass takes planning and risk, so each result matters more because it comes from a mission working at the edge of what its builders believed it could survive. And what it brought back is not just data for specialists. It gives all of us a new way to picture the biggest world in our neighborhood, not as a smooth ball with pretty stripes, but as a giant machine of heat, pressure, chemistry, motion, and electric power. That image is harder to hold in your head, but it is much closer to the truth. Another reason this story connects with people is simple. Hidden things pull on us. A cave behind a waterfall, a locked box in an attic, a signal beneath static, a door under old paint. Jupiter works on that same feeling, except the hidden space is not inside a house or under a hill. It is under clouds on a planet so large that more than 1,300 Earths could fit inside it. That scale can make the facts feel distant, but they are not. When we understand how a giant planet forms, mixes, and moves energy, we learn more about the rules that shape the whole solar system. Those same rules help set the stage for Earth's path. So even the strange things hidden below Jupiter's clouds connect back to the world we live on. And right now, scientists are still following those connections. They are comparing Jupiter data with computer models. They are using Juno's results to study exoplanets, which are planets around other stars. They are asking whether fuzzy cores are common, whether deep jets are normal, and how often giant storms move chemicals through upper atmospheres in ways nobody expected. That means the Jupiter mystery is not closed. The findings are real, but their full meaning is still being worked out. The story is no longer just, NASA found something below the clouds. Now it is, NASA found many linked clues below the clouds, and those clues are still changing what we think a giant planet can be. There is a quiet lesson in that. Sometimes the biggest scientific surprise is not a single dramatic object. Sometimes it is the collapse of a simple idea. With Jupiter, the surprise is that the planet is not built like the easy version many people carried around in their heads. Its hidden truth is a network of deep processes instead of one clean secret. You can feel that in almost every major Juno result. The fuzzy core tells us the center is not neat. The 3,000-kilometer deep jet streams tell us the weather is not skin deep. The water finding tells us one probe result was not the whole story. The shallow lightning and mush balls tell us even storm chemistry can break the rules we expected. Then the poles add giant organized cyclones. The Great Red Spot turns out to have roots reaching hundreds of kilometers down. The Great Blue Spot shows that Jupiter's magnetic field is uneven and moving. Each piece on its own is impressive, but together they say something larger. Jupiter is a world where hidden depth keeps rewriting the visible surface. What makes that so powerful is how familiar Jupiter used to seem. It hangs in the night sky bright enough to spot without effort. It has been watched for centuries. Its stripes appear so clear that it almost feels knowable. Yet one spacecraft arrives with the right tools, and suddenly the most familiar giant in the sky becomes strange again. That is one of my favorite things about real science. It does not make the universe smaller by explaining it. It often makes the universe larger, because each answer reveals how much richer reality is than our first guess. Juno did not remove Jupiter's mystery. It gave the mystery better shape, deeper stakes, and far more detail. If you could send one future probe into Jupiter's hidden layers, what would you want it to study first? The deep winds, the fuzzy core, the storm chemistry, or the magnetic engine? Write your answer below, and if you want more stories where one discovery opens 5 more questions, like this video and subscribe. There are still limits to what we can do. No craft can simply dive deep into Jupiter and send back a full map from every layer. Pressure would build brutally, temperatures would soar, and the environment would become deadly to any ordinary machine. So for now, much of Jupiter's truth still has to be inferred from careful remote measurements. But that does not make the findings weak. In many ways, it makes them more impressive. Gravity, magnetism, microwave readings, and repeated close passes let scientists read hidden structure the way a doctor uses scans to study what skin cannot show. It is indirect, yes, but it is still powerful, and it works. This is why phrases like "hidden below Jupiter's clouds" are not empty hype when used carefully. There really are things beneath those clouds that human eyes cannot see. There really are deep winds, mixed layers, buried chemistry, and moving magnetic features changing how experts understand the planet. The drama is real because the facts are already dramatic enough. And maybe that is the strongest way to end this mystery. NASA did not uncover one simple object waiting under Jupiter's clouds like a prize in a box. It uncovered a deeper truth about the whole planet. Jupiter is not a calm giant with pretty weather on top. It is a restless, layered engine whose hidden structure shapes everything we see from far away. The stripes matter because they reach down. The storms matter because they are not shallow tricks of light. The magnetic field matters because it points to impossible pressure and metallic hydrogen far below. The fuzzy core matters because it hints at a violent beginning and a planet that never settled into the simple form people once imagined. So when someone says NASA discovered something hidden below Jupiter's clouds, the honest answer is yes. NASA found hidden depth in almost every direction it looked. It found a giant world more complex than expected, more active than expected, and more connected from outside to inside than expected. That is what makes Jupiter feel alive in the scientific sense of the word. It is still there tonight, wrapped in clouds, turning fast, throwing storms across a world with no ground. Somewhere under that bright striped cover, deep winds keep moving, ammonia keeps cycling, and a magnetic feature keeps drifting through darkness. We cannot watch those things directly, yet we know enough now to stop pretending Jupiter is simple. If this changed the way you picture the biggest planet in the solar system, subscribe and turn on notifications so you catch the next mystery right when it lands. Then leave a comment and tell me which hidden Jupiter secret shocked you most: the fuzzy core, the deep jet streams, the mushballs, the polar cyclones, or the great blue spot. And share this with someone who still thinks Jupiter is just a giant ball of gas. Thanks for watching.